The next topic in linear equations that we're going to talk about is slope. A slope is a number that describes the steepness of a line. Slope is also called the rate of change of a line or of an equation. We also use the letter m to represent slope. So let's say I have 2 points on a coordinate grid and they're connected by a line. To describe in one number how steep the line is, what we're going to do is we're going to take the distance that it changes in the y direction and take the distance it changes in the x direction and make a ratio out of that, or a fraction. So we're going to take m and we're going to call that the change in y over the change in x. Shorthand, we write this little triangle, or delta y over delta x, which we pronounce the change in y over the change in x, okay? And this is slope. So the change in y means I can just count how many distance I'm moving upward. The change in x, meaning I can just count how far I'm moving forward. And I take the change in y over the change in x, and that gets me a number, or a ratio, and that will get me the slope. Another way we like to write this is slope, as a shorthand, is rise over run. It's just an easy way to remember it. How much did you rise over how much did you run horizontally? Okay, so we'll go into a little bit more detail in the next lesson, but for now we're just going to show you an introduction to slope. So for the different types of slopes, you might have a positive slope running uphill. You might have a negative slope running downhill. You could have a horizontal slope. This is actually called a zero slope, like the number 0, okay? And then the last type of slope is if you have a vertical line, that slope is called undefined. So I know here in Houston we don't have a lot of mountains, but if you're thinking about slopes as like ski slopes, a positive slope means when you're going up the hill, like on the ski lift. A negative slope is when you're going downhill, like having fun. A zero slope is like cross-country skiing. You're still on the slopes, you're just going flat, okay? This vertical line, this is not even a slope. You can't ski on this at all. This is a cliff. You would be falling. So this is an undefined slope. This is not even a slope that you could ski on. But you could ski uphill, you could ski downhill, and you can ski on the flat, but you just can't ski on a vertical. That's not skiing, it's just falling, okay? So that's one way I remember that. Next, I want you to identify the slopes of the following graphs, which means you have to identify two distinct points. So looking at this line, I can see a lot of points here, but I can see one really clearly there and one really clearly there. Please don't pick something like in the middle there. That's not going to help us count real easy. What I want you to do is I want you to find the slope by counting how far they're rising and how far you're running. So we're taking rise over run. How much did I go up? Well, I went up from one point to the next, 1, and I went over 1, 2, 3. So my slope is positive 1/3. It makes sense because it's going uphill, right? Now I could have used this point, and guess what? You're still going to get 1/3, okay? Even if you used like this point and that point, you're going to go over up 2 and over 6. 2/6 still reduces 2. 1/3. So your answer is still 1/3. No matter which 2 points you pick, as long as you count it correctly, you're going to get the same answer. Let's try the next one. I can see a point right here, and I can see another point right there. Okay, so how far did I rise? Well, I'm not really going up, am I? I'm going down. So when I'm talking about rise over run, I'm rising a negative 1, 2, 3, a negative 4. I'm running a positive 1, 2, 3, 4, 5, 6, it looks like. Now, 4, 6 can be reduced to negative 2/3. So my slope is negative 2/3. On the next one, let's pick 2 points. There's a lot of points I could pick here, actually. I'll pick this one and this one. How about that? But you could pick 2 other ones and you're still going to get the same answer. When I'm talking about rise over run, how far did I rise to get from one green point to the next? How far did I go up and down? Well, I didn't go up and down any. So that's 0. How far did I run? 1, 2, 3. In this case, the points that I pick, I ran 4. What's 0 divided by 4? Well, 0. But if you look right above, didn't we say that the 0 slope is a flat line? So this is just proof that the 0 slope is a horizontal flat line. And the next one, pick 2 points. Again, there's a lot of points I can pick from. I'll pick this one and this one. Okay, so I'm talking rise over run. How far did I rise to get from one blue point to the next? Well, looks like I rose 1, 2, 3. And how far did I run horizontally? Well, I didn't run at all, so that's 0. 3 divided by 0 is undefined. Remember we said a 0 under the line is undefined, which makes sense because a vertical line should give us an undefined slope. Next, I'm going to give you some information. I'm going to give you a slope and a y-intercept, and I want you to be able to graph. So I have a y-intercept at 0, 2. I'm going to always start with the point. 0, 2 is right here. Okay, so that's a point on my graph. Now, the slope, which we said is rise over run, I can get more points by doing rise over run. I'm going to rise 1, 2, 3 and run 1, 2. I could do that again. Rise 1, 2, 3 again, run 2 again. That's kind of off my picture, but it's still in line. Now I could do one other very interesting thing. 3/2 is the same thing as negative 3 over negative 2 because a negative divided by a negative is a positive. So if I went rise a negative 3, that's down 1, 2, 3, and run a negative 2, that is also on my line. If I keep doing that, down 3 and left 2, down 3 and left 2, that's also on my line. I would prefer if you get as many points on your picture as possible so you can get a nice, beautiful straight line. On the next problem, I'm going to start on my y-intercept. The y-intercept is 0, negative 3. Then I'm going to use my slope, 4. I'm going to write 4 as 4 over 1 so I can know which one is my rise and which one is my run. If you ever have a slope of a whole number, make sure you write it as a fraction because slopes like to be fractions so you can see the rise and the run. So if I rise 1, 2, 3, 4 and run 1, there's my next point. Rise 1, 2, 3, 4 and run 1. The next one's going to be off my picture. So the other thing I could do is rise negative 1, 2, 3, 4, down 4, and left 1. That's still on my line. For the next problem, my y-intercept starts at 0, 1, 2, 3, 4, 5 right here. Now my slope is negative 1/3. So I'm going to rise a negative. That means go down 1 and run a positive 3. So that's down 1, right 3, down 1, right 3. Do it as many times as you can. The other thing I could do is up 1 and left 3. The reason I can do that is negative 1/3 is the same thing as positive 1 over negative 3. So I could rise a positive 1 and run a negative 3. Notice it's all on the same line. For my next problem, I have a y-intercept of 0, -2, so I put my point on the y-axis at -2. My slope is 0, or you can write it 0/1, where my rise is 0 and my run is 1. So I'm going to go up and down none and run 1. Up and down 1, none again, and run 1. Notice this is going to become a horizontal line. But like we said earlier, a 0 slope is always going to get you a horizontal line. Next we have a y-intercept at 0, -4. So I'm going to start my y-intercept, my line at my y-intercept. My slope is a whole number, so I'm going to take my whole number and change it into a fraction. To change it into a fraction, I can always put it over 1. So my rise is -2, which means go down 2, and I'm running a +1. I could also rewrite -2/1 as +2/-1. That will get me to rise +2 and run a -1 in the left direction. So up to left 1, up to left 1, and then just keep repeating that pattern up to left 1 until you get all the way off your page. And our last problem, I have a y-intercept at 0, 1. And my slope is 5/4, so my rise is going to be a +5, and my run is going to be a +4. So I'm going to rise +1, 2, 3, 4, 5, and run 1, 2, 3, 4. Again, would put me off my graph. So what I could do instead of going up and to the right, I could go down 5, 1, 2, 3, 4, 5, and to the left 1, 2, 3, 4. And that's as many points as I can get, and I draw a straight line through that. And that concludes this first lesson on linear equations.